Okay, so continuing from the last video, what is a force? It's a push or a pull on an object that may result in a change in the object's motion. What else do we know? We know that it is a vector. Its direction is important. If I ask you to push a box down the hallway, you need to push it in the right direction. Maybe there are two of you and I say, okay, if you each push with a force of 40 newtons, you'll be able to move this box down the hallway, no problem. So one person pushes with a force of 40 newtons this way, and the other person pushes with a force of 40 newtons in the opposite direction. It's not going to be moving anywhere. Okay, so force is a vector. Force is measured in newtons, and we talked about that earlier in the year, and that's named after Sir Isaac Newton, who in a few sets of videos or so, will talk about Newton's 3 laws. There are two categories of forces. One category is called contact forces. Contact, there's no R there. Contact forces. And they are exactly what their name implies. It's when one object is putting a force on the other by physical contact. So if I actually touch it, push it, right? If there's one person and they have their hand on the other person's shoulder, then they're actually physically putting a force on them. I was going to give examples. Examples would be like a hockey puck on a ball, ice on the ball. The other category is brilliantly named non-contact forces. The non-contact forces, again, really messed up the early scientists. Think of Isaac Newton watching the apple fall. And Isaac said, okay, the earth must be putting a force on the apple to pull it down. And people were like, how could the earth put a force on the apple? It's not touching the apple. There's no way it can put a force on it. So it took Newton quite some time to convince people that you could put forces on objects without actually touching them. Examples of these ones would be gravity. Also magnetic force, right? Imagine you have a nice big strong magnet and you hold a paper clip. If you hold a paper clip some distance away, like so I have a horseshoe magnet maybe, right? And I hold a paper clip out here. As I bring the paper clip closer, there's going to come a point when the magnet's going to pull it in without it ever touching. And then there's the electrostatic forces. In maybe grade 9 science, you would have learned about the fact that a positive and a negative charge attract each other. They don't have to be touching to attract each other, they just attract each other. So contact forces, we see the two objects are actually in contact. Non-contact forces, they're not actually touching, but they can exert a force on each other. Okay? And no matter which type, they are a vector. All right, a few more little definitions. One is for mass. If you've taken chemistry, then you probably have a definition of mass in your back pocket already. But if you haven't, mass is simply the amount of matter that an object has. And this second part is important. It does not change as the object moves from place to place. For us, mass is usually measured in kilograms. Okay? Now, I define that one because of the word weight. The unphysicsed among us will interchange mass and weight, but they are not interchangeable. Weight is a force. It is measured in newtons. And where you are on the surface of the earth will determine your weight. Where object is determines weight. Now, more than that, you have to wait for. because I don't want to totally ruin the lesson where we learn about weight. But just know that they are not the same thing. One is measured in kilograms, the other is measured in newtons. So if you stand on your bathroom scale, or the unphysics people among us stand on their bathroom scale and they say they weigh 64 kilograms, they are just showing that they are unphysicsed. Their mass is 64 kilograms, but their weight would have to be in newtons, and I'll come back to that. Okay, a couple of other definitions. One is the word concurrent. Concurrent. I can't tell if where my paper is. If I'm writing angled or my paper is angled. Concurrent, as in concurrent forces. But you probably heard the word concurrent used in different ways, like as in concurrent events. Concurrent events are events that are happening at the same time. So concurrent forces are two or more forces acting on the same object at the same time. Two or more forces acting on the same object at the same time. Okay, so they're concurrent. And when two or more forces act on the same object at the same time, we have to add them together. Okay, and remember, forces are vectors, and we had 4 cases of adding vectors that we did way back at the beginning of the course. In case 1 was when the two vectors were acting in the same direction. So F1 is 40 newtons, and F2 is 40 newtons, and we put them head to tail, and we add them, and the resultant is simply 80 newtons in the direction that they were acting in. Okay? So if this was east and this was east, then this would be east. And so if you look back in your notes, you'll see this. It's add them and keep the direction. Case 2 is if they're acting in opposite direction. And if you remember, I had said when we were doing these are like borderline common sense. So we have 50 newtons east and we have 30 newtons west. And then when they're acting in the opposite direction, you just subtract them and keep the direction of the larger. So the net force, what you get when you add them together, the net force will be, 20 newtons. Be good if I could add 30 and 50. 20 newtons and keep the direction of the larger east. Okay? And then the third case was if they were at right angles. And if they were at right angles, you moved one head to tail and you found the hypotenuse, and then you had to find the angle. And then if you remember, the fourth case was any other angle. And there we either did components, right? We broke these up into the components, which we will get back to in the next video, or we did sine law, cosine law. Okay, so just a little note up here though. When two vectors are acting in the same direction, two force vectors, then you're going to get the maximum force possible from these two forces. And if they're acting in opposite directions, you're going to get the minimum force possible. Remember, if they're acting in the same direction, it means the angle here is 0 degrees. And if they're acting in opposite directions, the angle is 180. And in these ones are anything between 0 and 180. So if they're acting in the same direction, maximum force. If they're acting in the opposite direction, minimum force. Any other angle, something between the maximum and the minimum. So imagine that I said, I'm going to run out of time, I think, yeah. Imagine that I said, which pair of forces could produce a resultant of, let's say, 18 newtons. Okay, and so then I give you one pair, let's say 20 newtons and 40 newtons. Pair 2, 5 newtons and 25 newtons. Pair 3, 20 newtons and 5 newtons. And pair 4, 5 newtons and 40 newtons.